What I thought I would do, rather than give you a PowerPoint presentation, because I know you've never seen PowerPoint presentations, you probably wouldn't know how to take that. Rather than do that, I just want to make a few points, and then we can have Q&A. Just a little bit about my background. I'm a climate scientist, one of the people that other people don't like. There's actually an article today came out in Scientific American, an interview with me by a fellow who writes for used to write for New York Times and National Geographic magazines like that. And it's one of those things where you can post comments afterwards. It's already got some quality comments on there. But I guess the word asshole might apply to me. Jerk I am. Anyway, so I want to make a couple points, and then, like I said, open it up. One is, the first point is that sustainability is not easy by any stretch of the imagination, but it's really, the options are not that nice. So we can either achieve some level of sustainability, that is sustainable societies on this planet, or we can continue to bash away at each other. And I think the continuing to bash away at each other option is not very pretty if you actually look at what this means for the long haul. All right. The challenges of sustainability are many, and climate change is really just the first one. I like to say that it's training wheels for sustainability. And the big issue with climate change when it comes to sustainability is that if we're to solve climate change, we're going to have to figure out how to deal with each other on the whole planet. So we have to figure out ways for countries to come together on shared solutions. And that is not something that we do very well at all. The biggest environmental problems we've had to face so far have been ones in which the number of countries involved in the solutions are pretty small. So acid rain, for example, was a big problem in the 60s. Continues to be a big problem around the world, but acid glums onto water very, very quickly in the atmosphere. So acid stays in the atmosphere for a matter of days. And because the atmosphere only moves a fairly short distance in a matter of days, our acid rain, for example, generated in the eastern United States doesn't make it to Europe. China's acid rain just barely makes it over to California, and not in a way that's terribly measurable. So that means that China has to deal with the countries right around China when it comes to acid rain. The United States, we had to deal with two countries. One was Canada, and the other was Mexico when it came to dealing with acid rain. And Canada actually had very good reasons for dealing with this problem themselves, because it turns out that Canada had the most susceptible waters to acid rain, and so they really wanted to deal with acid rain. Mexico went along for the ride on that one. But it was a pretty small group of countries, obviously, that had to come together. And the United States was the big bully over here in North America, we just do whatever we want. I mean, people really think that Canada is its own country. That's one of the jokes that Americans throw around. My Canadian colleagues whack me in the back of the head whenever you say something like that. Anyway, greenhouse gases stay in the atmosphere a long time. Carbon dioxide, for example, stays in the atmosphere for hundreds of years, if not thousands of years. It has to do with some really interesting dynamics in the carbon cycle. But what that means is it doesn't matter who produces carbon dioxide from coal, oil, and natural gas. It's going to go in the atmosphere and it's going to change climate. And all of us are going to experience climate change. So it really doesn't matter in the end whether the United States burns coal, oil, and natural gas, or China, or Russia, or whatever. We all have to deal with the problems. And that forces us into a situation in which if we're to come up with a solution, that solution has got to be global as well. By the way, the carbon cycle dynamics are kind of interesting. I'll just tell you quickly why that's true, that carbon dioxide stays around so long. Turns out when we burn coal, oil, and natural gas and cut down trees and all the CO2 goes up into the atmosphere, about half of it goes into either the ocean or into land planes. So it goes up in the atmosphere and then actually circles back to the surface of the Earth. The ocean part of the ocean really wants to run the show when it comes to carbon. The ocean's got most of the carbon. And so the ocean is, to anthropomorphize, gets offended when there's too much CO2 in the atmosphere and says, hey, give me some of that stuff. And so it starts to dissolve in the ocean. So it's sort of like a bank. We burn fossil fuels, produce CO2, the CO2 goes into the ocean. That's a good thing. The ocean is actually helping us out a little bit by taking CO2 out of the atmosphere, and actually only half of the CO2 that we've produced is still in the atmosphere. The other half has gone into either the ocean or the terrestrial biosphere. The downside is that when, if ever, we decide we're going to quit burning fossil fuels and we reduce the amount of CO2 going into the atmosphere, and the atmosphere, you would hope, then wants to reduce its amount of CO2, it doesn't happen, because all that CO2 in the ocean then starts to come back out. So it's like a bank. And so what that means is that over long, long periods of time, hundreds of years to maybe thousands of years, the ocean's going to store this stuff and then give it back to us. So we really can't get rid of the CO2 in the atmosphere unless you actually suck it out of the atmosphere, which we could talk about. That's called geoengineering. And there's some people very seriously talking about stuff like that. So I think so climate change is training wheels for sustainability in the sense that if we can actually figure out how to get along country to country, then we've gone a long way towards dealing with much thornier problems. And by those thornier problems, I mean food. Right now, we produce about as much calories on the surface of the earth as we need to feed all the people on the surface. There's a lot of people who starve daily, and that's because we don't distribute the food well. But if population continues to increase, and it will continue to increase, what that means is that we won't produce enough calories to feed the people on the surface of the earth. And that's a fundamental problem. I mean, you've got X number of people, you've got to feed them in some way. Water is another big issue. Right now in industrialized countries, we use about 70% of the water that's available to us. And if you add another 50% of people, or if you add more uses of water, you can see why, for example, how many people here come from the eastern part of the United States? Does it rain back there? Yeah, it rains. But Atlanta has a drought, a big drought. And people in the southeastern United States are worried, this was a couple of years ago, worried sick about how they're going to deal with the fact that you just don't have enough water. Now in reality, it rains about 3 times more in Atlanta than it did here that year that there was a drought. It still rained a hell of a lot in Atlanta. The problem is that drought is defined not by meteorological parameters anymore, it's defined by how much water we use. If there are millions and millions and millions of people in the southeast who need water, then they define what a drought is. If the need is here and the water amount drops a little bit, then it's a drought. And that's what happened in the southeast. That, yes, there was a dip in the amount of rainfall, but it was still raining compared to what we're used to. It was still raining like crazy. It's just that there was a lot more people demanding water. And that is a flavor of what sustainability is. Do we have enough water? Do we have enough food? Do we have enough energy? Do we have enough raw materials? For example, if everybody on the planet drove a hybrid vehicle, that'd be good, right? Because we would have much lower gas mileage, much higher gas mileage, and we would all use less energy. The reality is there's not enough lithium, which is the batteries, which makes the batteries, to make all those cars. There's simply not enough lithium out there. And to throw on top of that the fact that lithium is mostly found in South American countries that don't like the United States at all, and you've got a fundamental problem. In an industrialized country like the United States, we want to build a lot of lithium batteries. We actually have to go and get other people to buy the lithium for us in order for us to get the lithium. So this international cooperation thing is a real thorny thing, but if we can figure out how to do that, then some of these other big problems I think we can tackle. The biggest problem when it comes to sustainability is the one that no one loves to talk about at all, and that's population. How do you get people to quit having people? We like to do that. It's not an easy thing to do, and it's a huge ethical issue to go to somebody and say, I'm sorry, you're going to get 1 kid, you get 2. You don't get any. Maybe naked, I don't know. But that is that, and I don't think we're going to have to do that where we actually do that. But in order, we got 7 billion people on the planet, and it's going up exponentially. And we'll make it to 8, 9, 10 or something like that. And like I said, we can't feed everybody today. We don't have enough water for almost enough water for everybody today. So there's a lot of issues with how do we deal with that many people. Now, population being a big, big problem is a multiplier on what I call the nasty dilemma, the secondary problem. And that is that resource consumption per capita scales somewhat with wealth. So if you plot resource use per capita versus GDP or whatever else you want, it's not a perfect relationship, but indeed, if you want to have a lifestyle like ours, or Japan, or China, or not China, Europe, Australia, etc., you need a certain amount of resources to do that. Energy, water, etc. So there's a certain amount of resources that go into that. Food also goes into that. And in order to scale this for you, as an example, well, let's not take us in the United States because we're wasteful. In Europe, for example, they use a certain amount of energy per capita. In China, that energy per capita is 5 times less. So they use 5 times less energy per person in China than they do in Europe. And Europe's pretty efficient. Now, China is already yanking the global economy up and down. When China wants more oil, our gas prices go up. When China wants more lumber, the cost of our lumber goes up. When China wants more concrete, a while ago China needed so much concrete that the price of concrete doubled in this country. And so we're 300 million people. They got 1 billion plus. And so what they do yanks this up and down. And there's still 5 times less consumption per capita than we are. Imagine if they came up to European standards on average. They would need 5 times more energy, 5 times more pretty much everything. And in some cases, the multipliers are even bigger than 5. Calories, for example, poorer countries tend to eat lower on the food chain. They eat a lot more rice, they eat more grains, they eat at that sort of first level of the food chain. Industrialized countries tend to eat more meat. And you got to feed a cow grain, and then you eat the cow. There's a factor of 10 loss of efficiency in that process. And China is eating more and more meat because they are industrializing in the same sort of ways that we did a while back. And we industrialize in a very unsustainable fashion, and they're simply going down that same pathway because the rules haven't changed much at all. So you take population, which is doing this, and then you throw on top of that a multiplier which could take population and increase it by a factor of 5. It's unimaginable. Then you got some real serious trouble. Throw on top of that the ethics of this. I mean, how many people in the room would like to see China stay down here? We got one. We got to take her. If you think about it, it's your fellow human being, right? And you really want them to live in poverty. We don't want that. We would like them to have a decent lifestyle. They don't right now. The vast majority of those 1 billion plus Chinese are living a subsistence lifestyle. They burn coal in the back of the house, or they burn wood in the back of the house. And yes, they've got a growing middle class, but they've got 1 billion people. So the middle class may be 100, 200 million people, and we're 300 million. So you can sort of see how the economy of China can make a big difference globally, but they've still got 700 billion people that have got to come into the system. Right? So, and that's where the huge challenges of sustainability really lie, I think, at least in my opinion. So I wanted to make 2 other points here. One is on the issue of climate change. We hear a lot about climate change. We hear a lot about, is this real, is it not real, all this stuff. I am occasionally mystified, only occasionally, that I've become a little more savvy when it comes to politics, about why people don't think that climate change is happening. But let me just give you sort of some basics. If you take a step back and you just look at the globe, right, and you ask what are the simple physics that drive our climate system, it's remarkably simple. There are really only 3 things that you need to know in order to know the temperature of our planet. You need to know how much energy we get from the sun. You need to know how much of that energy is reflected off the white bits of our planet, and that would be snow, that would be aerosols, sulfate aerosols and things like that up in the stratosphere, the reflected parts. And you need to know how much greenhouse gas there is in the atmosphere. If you know those 3 things, if you have a record of all the greenhouse gases over time, if you have a record of how the sun is behaving, and the sun has all sorts of cycles to it. It has sunspot cycles. You probably heard of those. How many people heard of sunspot cycles? The orbit of the Earth changes around the sun, so at times we are farther away. At those times we've had big glaciers on this planet over the last million years. Huge amounts of glaciation. So the sun-Earth relationship changes a little bit. The reflectivity of the planet changes. When we have more snow on the surface, we get colder. And when we get colder, we have more snow on the surface. That's a positive feedback, so the Earth tends to cool off. But all you need to know is those three things. And you can, you could take a sophisticated climate model, you could just take an Excel spreadsheet, and you could take those three variables, and all of you could then create the temperature over the last 150 years, and you do a very, very good job. And what you would find is that since about 1970, you cannot reproduce the temperature of our planet without having huge increases in greenhouse gases. Roughly around 1970 was the time at which we could definitively say that human beings are changing climate on the planet. And none of what I said is controversial. This is very simple physics. This is the simplest stuff. Like I said, you don't need sophisticated models to do any of that. As a matter of fact, it's important to recognize that greenhouse gases are absolutely essential for life on the planet. And not just because CO2 is, if you've never seen the commercial, it's a classic, CO2 is life. And it's basically produced by oil companies saying that CO2 actually is used in photosynthesis and that's the basis of life on the planet. So how come, what's all this fuss about CO2? Well, they're right, CO2 is the basis of photosynthesis. But you can always have a little bit more, too much of a good thing. Maybe not too much of it, just sort of enough of a good thing. It turns out that the Earth from the sun is too far away for us to be a liquid planet. The temperature of the planet, given how far we are away from the sun, is about 18 degrees Celsius below zero. If we were closer to the planet, we'd be warmer. If we were farther away from the planet, we'd be even colder than that. So you get that. That's right. So as it turns out, the Earth is not close enough to the sun to be a liquid planet. The ocean should be frozen, everything, it should be cold, we should not be here. The difference is that when you put greenhouse gas in the atmosphere, it warms the planet up. And our actual temperature of our planet is plus 15. So that's about 33 degrees Celsius, or about 60 degree Fahrenheit increase in the temperature of the planet. All of that's done by greenhouse gases. It makes the planet habitable. Water vapor, CO2, methane, nitrous oxide, those particular gases are the ones that make the planet habitable. Nobody argues about this. None of the physicists, none of the chemists. This is all very, very simple stuff. You should learn this in basic earth sciences. And if you haven't learned it, somebody screwed up somewhere. It should have been taught. Now, if you want to argue about whether or not the Rockies are getting wetter or drier, or whether or not it's getting warmer or colder here in Colorado, that's where sophisticated climate models need to be applied, and that's where we have very rich arguments about climate change. But there is no argument about whether or not temperature is increasing, because we have good thermometers that tell us that's true, along with a ton of satellites. And no one who understands even basic physics argues about whether or not human beings are causing that change, because we are. The third piece of this is you can't deny physics. You can't get out of it. It doesn't matter what politicians say. It doesn't matter what business people say. Climate's going to change, whether Congress wants it to or not, or whether some oil company wants it to. It's going to change. It's like gravity. You don't have a choice about. Can I borrow you for a second? Mm-hmm. Stand on the chair. All right. Now, what would happen if she just plunked over? Yeah? But in detail. Come on, let's talk about details. What would happen? Let's say you put your arm out. What's your name?
Nicole.
Nicole? What if Nicole put her arm out to catch herself? What would happen to her arm?
Go ahead and break it.
Probably break it. Is it 100% sure she'll break it? What are the odds? Pretty good, right? So what if we told her, all right, Nicole, let's keep your arms behind your back. All right, now we're going to have her tilt forward. Maybe break her nose or something. How come in none of this conversation anybody has brought up the fact that Nicole won't fall? It's common sense. It's common sense. If you put greenhouse gases in the atmosphere, the Earth is going to warm up. The details we can argue about. Whether or not Nicole breaks her arm or smashes her nose into the table is a detail. Is something going to happen to Nicole? Absolutely. You can't get around gravity any more than you can get around the basic physics of greenhouse gases. The basic physics of greenhouse gases we actually understand better than we understand gravity. Gravity's still a little bit of a mystery. Keep it down now, safely. So if somebody says to you, this greenhouse gas stuff is a load of crap, the response is, no, it's not. It's basic physics. what human beings do about it is where we have arguments, where we should be having arguments, where we should be having adult arguments. It's a silly, childish argument to say the Earth is not going to warm up if we put greenhouse gases in the atmosphere. It's a far richer and more sophisticated argument to actually argue about whether or not it's a good thing or a bad thing for the planet to warm up. I can tell you this, the planet has been much warmer in the past than it is today. The planet has been much colder in the past than it is today. Life continued throughout all of that. We are not going to make this planet so hot that life can't continue. We are causing species to go extinct. Right? So not everybody makes it to a warmer planet as elegantly as some species. Some species die out, some don't. We're the only creature on the planet that I know of that sits back and thinks about this stuff and can actually weigh whether it's right or it's wrong to cause another species to go extinct. We can actually weigh whether or not it's right or wrong for us to, for example, cause sea level to rise, or to cause precipitation patterns to change, or all the other things that go along with climate change. And really, in the end, in my opinion, it's that ethical discussion that has not been happening. We hear a lot about climate change, and then the first words are, it will hurt the economy. If we do anything about oil, coal, natural gas, it's going to hurt the economy. Now, the economy is important. We all worry about money. But is the economy the only thing we need to worry about? And the answer is no. We are also capable of thinking what's right and what's wrong, and so therefore we're capable of balancing money versus what's right and what's wrong. So don't fall into that trap either when people say, yeah, but it's going to hurt the economy. Yeah, but you know what? I don't like the idea that I'm causing species to go extinct. I don't like the idea that there are other people out there who are taking the brunt of climate change, and I'm just doing whatever the hell I want to do. I'll give you an example. One of the very, very, very robust correlations on this planet is that if you warm the planet up, sea level rises. That happens because of two simple physical principles. Number one, warm water expands. Can't stop it. You can back up in a chair if you want to. Can't stop that. The second is when you warm the atmosphere, you melt land ice. And land ice runs into the land ice, melts the water, flows into the ocean, raises sea levels. If you plot the temperature of the planet over the last 60 million years, and you plot sea level over the last 60 million years, they are very, very, very well correlated. Right? When you're warmer, higher sea level. When you're colder, lower sea level. So sea level goes all up and down all over the place. For the last 10,000 years, we've had a pretty stable climate, and sea level has been relatively stable. And so we built large, large cities right near the ocean. We built entire countries right near the ocean. Do we expect sea level to stay level or stay where it is forever? No. It's going to either go up or down whether the climate gets warmer or colder. We're getting warmer, sea level is rising. It's rising right now. By the year 2100, easy prediction, sea level will be about 3 feet higher than it is today. 3 feet. Is that meaningful? How does 3 feet sound? Sound bad? Sound good? Sound like a problem? Why do you say yes?
I mean, like, how big the ocean is, and if it rises 3 feet, like...
That's a lot of water.
That's
a lot of water. But you know, there's a lot of ice in Greenland, a lot of ice in Antarctica. I worked there. I know, I've been there. A lot of ice. And that's what happens. It melts and goes into the ocean. As a matter of fact, if Greenland, if we go back to the last time the Earth was as warm as it is today, the last interglacial period, and you look at how high sea level was, about 5 meters higher. That's like 18 feet or something like that. 18 feet is a lot of feet. 3 feet. 3 feet actually will render the city of Miami useless. 3 feet will make the toilets not flush. When you flush a toilet, it goes downhill. Gravity is what makes the system function. Right? When the bottom of the gravity rises up, you're in trouble. All the electrical lines, if they're not run above ground, all the gas lines, they're run below ground. The infrastructure of a city doesn't work well with salt water intrusion. So what do we do about Miami? Are we going to save Miami? This is your world. I'm sorry, but my generation is giving you this, and we're going to ask you to sort this out. Do we save Miami? How many people would vote yes, we save Miami? How many people say no, we don't save? For those of you saying we're not going to save Miami, you're being practical. Florida is a whole bunch of sand and a whole bunch of carbonate. Carbonate rocks are shot full of holes. If you build a dike all the way around Miami, it won't make any difference. The water just comes up. Miami's hosed. Miami has no future. That's a very easy statement. A difficult thing to hear and a difficult thing to say, but a very easy scientific statement. As a matter of fact, you can also ask some fun questions. You know, how high was sea level last time we had 400 parts per million of CO2 in the atmosphere? We're at 390 right now. We'll get to 400 quickly. We go up about 2 per year right now. So you ask, what was climate like last time we had 400 ppm of CO2 and the sun and the earth were in the same relationship they are today? Remember those 3 things, right? Well, it turns out the climate at that time, it sat stable for long enough that the Arctic warmed up and Antarctica warmed up, and most of that ice melted off. Sea level was about 80 feet higher at that time. 80 feet. Now, 80 feet's interesting. At 80 feet, you lose a state. Guess what that state is? Geography. No, Louisiana. You know what's sad about Louisiana? It's not a boot anymore. You amputate the foot. So I think that was the only state I got right on mine. I grew up in East Tennessee, so we didn't have huge tests back then. But anyway, anybody guess what state it might be? It could be Delaware. Might be Delaware. We lose Delaware. Basically, that whole Delmarva Peninsula goes underwater. Florida, cool thing about Florida is that right in the center part of Florida, the land's high enough that it remains kind of an island out there. And I love to say this every time I talk about sea level rise. What's in the middle of Florida that's really, really, really important?
Disney World.
Bingo. So the Disney princess will sail right up to the United Now, this is where critical thinking comes in. Right? So who benefits greatest from global warming? Right? So who would benefit then? Wouldn't Disney benefit from global warming? So who's responsible for global warming? Follow the money. Think about it. I'm not serious. Of course, Disney's not behind global warming. But it's a good example of there's winners and losers. And that's really I think the fun part of sustainability is fun. The fun part of sustainability is figuring out how to get from here, which is a very unsustainable pathway, to where we want to be in a way that we minimize the losers and we maximize the winners. That's an elegant solution. We can get there inelegantly. We can get there by starvation, we can get there by war, we can get there by genocide, we can get there by a whole bunch of very nasty things because we have to pare the population down. But we don't have to. And interestingly, as I say, I'll finish up with this because I want to take time for questions. It's said that every generation has its challenges. And well, I think what I've just laid out is one of your big ones. Is it solvable? Absolutely. I mean, the options are not good. You have sustainability and you've got the other stuff out here, and the other stuff's not terribly tantalizing. But I'm 100% sure we can get there. 100% sure we're smart enough. And the reason why I say that, and I'll show you my bias. So here's my bias. It turns out that a lot of the solutions to things like population and things like that have to do with equity. If indeed we treat each other better, then a lot of the problems that we have around the world get smaller. Population's a good example. The status of women around the world stinks. It's horrible. In large parts of the world, say 4 to 5 billion of the 7 billion, women have no value other than babies. They do most of the work, they own none of the property. It's not a good situation whatsoever. In areas where women are valued, population goes down, birth rates go down, because women have value beyond just being baby makers. One of the great examples of this is there's a camp in India where instead of saying we're going to change access to birth control and all this stuff, they said we're going to change the empowerment of women. They dissolved government and they reformed it with 50% men and 50% women. And population growth rates went down. Right? That's just an example. There are lots of other equity issues. The rich countries treating the poor countries better. Keep in mind that I have only 3 rules of sustainability, and one of them is that you've got to maintain some level of equity. Because if there are people who are outside of the economic benefits and all the other great benefits of the planet, they have no reason to not trash the planet in order to get their daily bread, in order to get to heat their homes and all the other things they have to do. So if indeed we all treated each other a little bit better, a lot of this stuff gets a whole lot easier. And maybe that sounds hard to you, but hopefully it doesn't. I'll take questions. I don't want to depress you guys. You're the problem solvers. And like I said, one of the greatest things that I get to do is I get to teach. And, it's impossible to be a pessimist when I look at you guys and you go, some people out there who are very bright, who understand how the world works, and are willing to make a couple of $1 billion. Yes.
Yeah, I was wondering, what happened in Hawaii? You're talking about Florida and Delaware.
Mm-hmm.
When the water levels are really high or whatever. With Florida, was Disney Island, and
right.
Delaware's gone. What happened in Hawaii?
Hawaii actually does pretty well because Hawaii, being a volcanic set of islands, it's got a lot of topography. Sea level would have to go up a long way in order to bash Hawaii. One of the coolest things, by the way, I should be cool. When I talk about this in public talks, I show. Anybody here from Oakland? Sorry, gotta say.
Well, that area.
Yeah.
East Bay.
It's underwater.
To how far?
For most people here in Denver, it's just a question of whether or not Oakland Alameda County Stadium is underwater.
Do you know anything about Contra Costa County? Or?
I don't know. But interestingly, that whole East Bay is underwater.
What about the peninsula?
Wow. Huh?
What about the peninsula?
Peninsula, a little bit underwater, but the interesting thing is that Sacramento is underwater.
That's not a big deal.
Water, there's a channel right through there into the Imperial Valley.
Right.
A huge chunk of the Imperial Valley is underwater.
That's how it used to be, isn't it?
Mm-hmm.
Isn't that like a huge...
Just like from the delta and just feeds.
Yeah, it just feeds. Yeah. So we'll be building dams. Maybe they'll build something across where the Golden Gate is to save Oakland. Maybe they won't.
Well, I just want to know how far in, because I'm like.
Well, the good news is that you can buy a lot of beachfront property up in the hills. Particularly if you go inland, there's still not. I'm sorry.
What time frame were you talking about?
Oh, for sea level rise? Sea level rise is slow burn. 100, 200, 300, 400 years, something like that, before you start to get, 3 feet at the end of the century, but it doesn't stop there. The ultimate limit of sea level rise is probably, 50 feet or something like that, or something, even given the greenhouse gas at the end of the day. But it'll take several hundred years to get there. But on the other hand, I don't know how to stop them. Once these things start going, it's very, very difficult to stop them. Yeah?
How are ideas that in the next 10 years California is going to be underwater and stuff like that able to be in the news and stuff like that if a ton of people know the simple facts, know the truth and stuff, but how are we still listening to people say that we're all going to be dead in 10 years?
I don't know. I wish I knew the answer to that. I think in part it's because we haven't been teaching this stuff. And when we do teach it, unfortunately, scientists love details. We love to argue with each other about details. We are very much incapable of communicating basics. If you've taken a science class, you know what I'm talking about. So, and that's just, in part it's because of the way that scientists work. We have the scientific method is a great way to do science, but it's a terrible way to run your life, and it's also a terrible way to talk to the public. The scientific method basically puts up a hypothesis, and then everybody in the neighborhood tries to knock it over. So imagine, if you ran your court system that way, it'd be terrible. Okay, OJ, we think you're guilty, but now we got to prove, basically everybody else in the world couldn't have done it, so OJ's the last one standing. You can't run your life that way. We run our lives under uncertainty and all these things, and so I think in part it's because scientists haven't been able to get out there and get the message out. It's also because there's a lot of money involved. I'll give you an example. You all heard of the Arctic National Wildlife Refuge, so northern Alaska. A lot of debate about whether we should go after the oil there. That amount of oil is maybe 6 to 8 months worth of the U.S. supply. So it's not that much in terms of our need for oil. We've got an enormous need for oil. But it's still $1 trillion. $1 trillion. So does ExxonMobil have an interest in this? Absolutely. Does BP have an interest? Does Shell have an interest? Of course they do. There's so much money in 6 months of the U.S. energy supply that you can see how misinformation or agenda-driven issues just become the rule of the day. It just makes all the sense in the world to me. When you got that much money tied up, U.S. So if the U.S. got an energy bill at the end of the day, at the end of the year, say you owe, and they had to write a check, or we had to write a check. It's $1.4 trillion per year right now. That's our energy bill. So it's roughly $100 billion a month, which is more than your energy bill. Any other questions? I know I'm going to leave Dave some time.
Yeah, do you know anything about ocean acidification? Like with the CO2 going absorbed into the...
Yeah, no, CO2 will absorb in the ocean. The oceans are acidifying. They've gone down in pH. That makes it much harder for shell-forming organisms to live. So coral reefs are under attack right now. Any shell-forming organism is finding it harder and harder to survive. We know that shell-forming organisms have existed in acidic oceans, not really acidic oceans, but acidic enough. So there are refugia out there, places where they can sit and hide. But it will definitely change ecosystems in the ocean. It already is changing ecosystems in the ocean. And that's, we don't know what that does on top of the fact that we already have greatly changed ecosystems in the ocean by overfishing some species and changing the food web that's already out. I think pumping CO2 in the ocean is a bad idea also because of that. Because you just definitely acidify the ocean doing it. Yeah.
You say like on a global standard we have to start treating each other better.
Yeah.
But what can us as individuals do to help, I guess, fix the problem?
The most impactful thing that you can do is, well, 2 things. Number 1, educate yourself. Learn about this stuff. And number 2, vote the way that you feel makes a difference. In a democratic society, if you let your Congress folks, your governor, your president, whatever, know, I care about these issues, and I will vote along these lines, then there will be action. As long as we don't care about that, and study after study have shown that while people are worried about climate change, worried about global warming, they're just beginning to think about sustainability, we don't vote that way. So if you think these are important issues, let them know and tell them you're going to vote that way, and there will be change.
You talked about population, and that to me has always been the foundation of all the problems that we have.
Yeah, if you got 7 billion people, you got real resource needs. Yeah, there's been a number of studies that tried to estimate if we all wanted to live at a European level, how many people could we have on the planet? And answers vary, but 2 billion is a number that gets kicked around a lot, anywhere from 1 to 5 or something like that, or 1 to 4. We're at 7, so we've already overshot the runway, and the question is, how do we get back to that level?
And the other problem is the economic models, all built on expansion and consumption.
Yeah.
Boy, that seems like a...
Yeah, there's a collision between classical economics and the environment or environmental economics. My simple take on that is that if you ask people what is the greatest good here, what does he want? And if you ask economists, it's all about growth. If you ask people, a lot of it comes back to quality of life. I would like to have a high quality of life. You don't have to constantly have growth in order to have a high quality of life. But at some point in the last 30 years or so, quality of life just got, maybe it's good enough for all of us that we don't think about it. But it just got shoved to the side, and growth became the overarching, that's our God now. Growth is our God. And no, you cannot continue to grow and have a sustainable world. I mean, you know, you can grow in terms of quality of life. You can grow in terms of your intelligence. You can grow in terms of your ethical well-being. You can grow in terms of your morals. You can grow in terms of how we treat each other. There's all sorts of ways that we could grow as a species into a much happier species. But you can't just keep adding people to the planet. And you can't just keep consuming more and more, because there's not more and more to consume.
But it's always amazing to me that that is the one thing that nobody will speak about in, you know, political. We have it here.
We have it on iPhone.
Somebody will come and get us.
iPhone-age, that's right, yeah. Any other questions? Yeah.
I was wondering about solar panels, like
Yeah.
solar energy. Like, what if? Because I know that there are like some ideas for like preventing the sunlight to get into the Earth and like heating it up by putting like meters out in space.
Yeah.
What if we like?
No, people are very serious about that.
Yeah, I know. Because I know Arnie said something about the governor, you know? He said something about solar panels. I forget what he said, but like, what if California did like, say, 50% of the houses had solar panels? What would that do to the environment?
Oh.
Like, would that reflect the sunlight, or would that absorb it?
No. The idea behind solar panels is actually to absorb
Okay.
at least some of the sun's energy.
Okay.
If you're not absorbing some of the sun's energy, then you're not getting bang for your buck. They're probably a little more reflective, but you can make them darker.
Okay.
And so, although at the heart of your question, I think, is a very interesting question, which is, can we provide energy to 7 billion people at the kind of level that we're going to need to as China industrializes and Indonesia, and not have environmental footprint? And the answer is no. I mean, I very emphatically know. We will have an environmental footprint. We will change climate. We will. We just have to learn to live with that. We have to learn to manage that footprint. There's no way in a sustainable world that we're going to live on this planet without having a footprint. Another good example of that, well, for example, if you put, here's a metric for you. If you want to run the world's energy needs off of wind energy, you would basically have to rob or take out all the energy in the lower atmosphere on land in order to do that. There's that much energy there relative to our needs. So you can't run the world on wind. And if you did that, you would fundamentally change climate, because winds carry energy and they carry moisture and they carry all this other stuff. So if we build lots and lots and lots of windmills, we will change climate. If we build lots and lots and lots of solar panels, for example, let's put solar panels down in New Mexico. You know, it's only aliens, right? So it's right around Roswell. What that will do is it will change the energy budget of Texas. It will. And there's a whole bunch of people up at NCAR and other places who are studying this right now. If I concentrate my energy collection in point A, downwind of point A, or down energy of point A, something fundamentally different is going to occur. And so changes are going to have to occur. Which is, I mean, either that, or like I said, we have to ramp back or amp back on the number of people and on our consumption. And I don't think we're going to cut back on consumption, to be quite honest. We have comfortable lifestyles. We're not going to crawl back in the caves. And on that cheery little note.
Well, thank you so much for coming in. That was fantastic.
Turn it on. Sorry to take more of your time.
Yeah.